Hi everybody, in this video we are going to be going through a engineering problem, and along the way we are also going to be walking you through how to solve these types of problems. So get a pen and a notepad and then we'll get started. Jane and Michael are collaborating on a project. If Jane first worked 6 hours, then Michael will need to continue working for 12 more hours. But if Jane first worked for 8 hours, Michael would need to continue working for 6 more hours. If Jane first worked for 3 hours, how much hours would Michael need to work in order to finish the project? So how we're going to do this is by creating equations out of that and setting up variables. So how we're going to do that? First, we highlight what we know. We know that if Jane first worked 6 hours, then Michael would need to continue working for 12 more hours. But if Jane first worked for 8 hours, Michael would need to continue working for 6 more hours. And the problem is, if Jane first worked for 3 hours, how much hours would Michael need to work in order to finish the project? So what equivalent values can we see from the first highlighted section? I'll read that part. If Jane first worked 6 hours, then Michael would need to continue working for 12 more hours. So yes, we can set X as Jane's unit progress and Y as Michael's unit progress. Remember, unit progress means the progress a person makes or a team makes in a unit of time, like per day, per minute, per hour, per month, per week. That is unit progress. And let's just set the whole amount of the project as 1. So 1 is going to represent the whole amount of the project. Okay, so from that, what can we get? Well, Jane's unit progress is X, and she's working for 6 hours. So that means the unit of time in this problem would be using hours. So we could just multiply that together as 6x. And then it's adding the progress of Michael. Michael's unit progress is Y, and he is working for 12 more hours. So that's 12Y. And they add up, so they equal 1. They will finish doing the whole amount of the project. Now I want you to pause the video and, just like what I just did, write the equivalent equation for the second section that we've highlighted. What did you write? If you got 8x plus 6y equals 1, then you were correct. Now we have these two equations. What are we going to do with them? Now here, watch. This could be a very useful solution for any type of problem, not just solving engineering problems. Watch. First, I add curly brackets around these equations that I have to show that it is one group. Then I give to the first equation the name equation number 1 and then equation number 2. Now, what I'm going to do is draw an arrow, and above the arrow, I'm going to write equation number 1 minus equation number 2. So what did I just do there? You don't always have to minus equation number 2 from equation number 1. You can do any type of operation with them. But I am doing this just because it will help us with this problem. So what does this mean right here? Equation number 1 minus equation number 2. It means we're subtracting this whole expression from this first whole expression. So we could write that as 6x plus 12y minus 8x plus 6y. Remember to add those parentheses. So the left side is going to subtract from the left side, and the right side is going to subtract from the right side. That would be 1 minus 1. And now we're going to simplify. First, we're going to remove brackets. That's just going to give us 6x plus 12y minus 8x minus 6y equals, we simplify the right side, 0. Now we combine like terms. First, we have 8x minus from 6x. We combine them, it's negative 2x. And then we add the difference between 12y and 6y, which would be 6y. That would be equal to 0. Well, to solve easier, I want to make both values positive. How do I do that? All I have to do is move this negative 2x term over to the right side, where it becomes 2x. So 6y is equal to 2x. Now let's pause for a moment and go back. So, let's think. What does the variable x stand for? Yes, you were completely correct. X is equal to the unit progress of Jane. And what does y stand for? Yep, y is equal to the unit progress of Michael. And what is the problem again? What did we underline in the problem? The problem was that if Jane worked for 3 hours, how much hours would Michael need to work? Okay, so Jane first worked for 3 hours. Let's put that in. How do we change 2x into 3x? How do we do that? Well, we just have to multiply 1.5 on both sides of the equation. We multiply it by 2x, we also have to multiply it to 6y times 1.5. Now we simplify, that gives us 9y is equal to 3x. Boom, we've solved the problem. All we have to do now is know that if Jane worked for 3 hours, Michael would need to work for 9 hours. Remember, I'm just quickly writing this, but when you are doing this maybe in class, you have to remember to write in a full sentence. I just did this because it will be quicker. So the answer is Michael would need to work for 9 more hours in order to finish the project. Pause the video and take a look at what we've done here. What did we do? Well, we first just wrote down and found the equivalent values from the facts the problem gave us. And then we thought up with this solution. We subtracted a whole expression from another whole expression. If you don't know what I'm talking about here, we right now have a 7th grade slideshow lessons that you can find on our YouTube channel. So you might want to click our channel and go and check that out. And it's talking all about this in those videos series. So if you don't get what I'm talking about here, you're probably going to find that one helpful. So basically, we subtracted the second equation from the first equation. And then we had to simplify. Then over here, this is key point. This is key point. We stopped and we went back and looked at what x and y stood for. Then relearning what that was helped us say, well, if x is equal to the unit progress of Jane, and we need to change it into 3x, all we have to do is multiply a 1.5 on both sides. So we multiplied a 1.5 on both sides, and it gave us 3x equals 9y. So Michael would need to work 9 more hours, and that was the answer. And another important part in the beginning, actually, was if you don't know, or if the project hasn't given you the total amount the project is equal to, just put it as a 1. It's a whole project. And when you're first learning about the fractions, what represented a whole? 1. 1 is equal to 1 whole. So thank you for watching this video, and remember, if you don't know at all what I was talking about here, always remember to come to check out a playlist that we have on our YouTube channel on the whole 7th grade math series. We have many lessons in there in order, and you might want to check it out. Also, make sure to subscribe, comment, share, add a like, and click the notify bell after you finish this video. And one of the best things you could do is go down into the descriptions and read it. Then you can click onto our website and learn more about us. So, see you next time. Remember to check out our playlist, subscribe, and we'll see you next time.